All right. Hopefully my coughing happened before the sound kicked in, but if it didn't, I apologize, right? Not trying to blow anyone's ears out here. All right, so we're going to solve one more equation here, all right? And so what we're doing, we're solving these by graphing, okay? And so I'm not doing the algebraic solutions just yet. Doing graphing. All right, so we've got this equation here, and remember that we want to see it looking like this, okay? It doesn't look like that, does it? So what we're going to do is we're going to move everything over to one side. And so what I, generally speaking, my strategy with these is always to look at your x squared term. And if your x squared term is positive, leave it where it is. And if your x squared term is negative, then move that and everything that's on that side over to the other side. Okay, and the reason I do that is because I like working with positive coefficients in front of the x. I don't know why, just the negative ones kind of make me uncomfortable. And that's completely silly, but it's the truth. And so because we are solving this by graphing, it doesn't really matter, you know, if it slightly alters the equation a little bit, because it's going to get us to the same place, right? So let's take a look at this, all right? So we're going to move my x squared, right? So we're going to move this, and we're going to move my 14. We're going to move them both over to the other side. So we're shipping them out, and we're making this one side 0. So we're going to have 0 is equal to, well, when I move, let's move my x squared term first. When I move my negative x squared over, it is going to change signs. So if it's negative now, it's just going to be positive x squared, and there's nothing to combine it with over here, so we just leave it sort of where it is. And then I'm going to write my negative 6x because there's nothing coming over that's going to change that. And then I've got this plus 23, but I've also got this 14 that's moving across the sign. And when the 14 moves across, we're going to combine it with that negative 23. But we got to remember that because the 14 is crossing the equal sign, right, it changes signs. So it becomes a negative 14. So we have negative 14 plus 23, which gives us positive 9. All right. We're in good shape here. All right, so let's find our axis of symmetry using our good old trusty equation that we should all have burned into our head by about now. So we go negative, negative 6. Or another way of thinking of it is the opposite of this. Well, the opposite of negative 6 is going to be positive 6. And so you'll see that's going to drop away in a second. And then we have 2 times 1. My a is my coefficient in front of x squared. If there is nothing, you just make it 1. All right, so we have a negative negative. That makes it positive 6. And then 2 times 1 is 2. 6 divided by 2 is 3. All right, so for my vertex, right, I've got 3, comma, and then we'll find my y-coordinate in a second. So we're going to take this 3, and we're going to put it into this equation right here. I mean, we could put it in here, right? You could put it in either one, but this one's just a little easier to work with. So I'm going to say 3 squared, because it's x squared, minus 6 times 3 plus 9. Great. You get 9 minus 18 plus 9. Okay? So I have 9 and 9, so that's going to give me positive 18, minus 18. Oh, I love it when they're this simple. 18 minus 18 is 0. And so my axis of symmetry is running through x equals 3 right here, right? And then my point is right here. That is my vertex. And because of the way I rewrote the equation, my x squared term is positive. And because my x squared term is positive, this thing is going to open up. Okay? So let's verify that. Okay? So let's say x, move you here. My equation is x squared minus 6x plus 9. And then when I plug into that, that's going to give me y. All right. So if my vertex, if my x-coordinate of my vertex is 3, the next two integer values would be 4 and 5. So we got 4 and 5. So we go 4 squared minus 6 times 4 plus 9. Well, that's going to give me 16 minus 24 plus 9. Well, 16 minus 24 is negative 8 plus 9. You add those two together and you get negative 1. Okay, so my next point the point, -1. I am so confused. It's not -1, guys. It's 1. So I don't only make mistakes in person when I'm teaching the lesson, but apparently in video lessons, right? So at least you know it's authentic and not like a robot or something. Not that any robot would be this disorganized, but you never know. So 0.41. So let's go over 4, up 1, boom. All right, 5. Put it in. All right, I'm just putting it wherever I see my x's, and I'm using this equation right here. This is the thing we're using to substitute in for. Okay, so we've got 5 squared, which is 25, minus 30, because that's what 6 times 5 is, plus 9. So that gives me -5 plus 9, which gives me positive 4. Right. The fog is starting to lift. So 1, 2, 3, 4. Let's put that there. Now I'm going to reflect both of these over my axis of symmetry. All right, and then we'll draw something that actually does not look terrible. And neither does that. This is one of the better parabolas I've actually mustered in a while. All right. Now, my vertex, remember, is always the point where this thing crosses the x-axis. Well, in this particular case, it doesn't really cross the x-axis. It touches it, kind of sits on the x-axis, right? So my solution is going to be the point x equals -3. Okay? And so that is my one solution, right? And now we will, when we start factoring these, we will realize that ones that look like this, that give us what appear to be one solution, there is actually 2 solutions. It's just that it's called a double root, right? A double root. Now, that doesn't have to necessarily ring any bells or mean anything to you right now. But I just want to iterate the fact that even though it looks like there's just one solution to this, technically there's 2. Okay? But like I said, not trying to confuse you. This is the answer. You write it like this, you're in good shape. You understand what you're doing. But it is a double root. Okay? So again, hope this is helping you. Go on out and graph as many of these as you can and get the hang of it. And just remember that the solution of a quadratic equation are the points where the equation crosses the x-axis, right? It's where it crosses the x-axis. So I hope this has been helpful to you, and good luck with these.